Welcome back to Mat 140. I want to continue our discussion, and today we're going to be talking about symmetry. Symmetry is a really important topic in college algebra, and it really helps us to solve some difficult problems sometimes by just noticing, oh, the function is symmetric. So let's talk about three kinds of symmetry. The first one is the most obvious. We call this symmetry about the y-axis. Now in this case, the mirror is along the y-axis, and so it allows us to consider points on this side to be reflections on the other side. So that would be what we consider the mirror point. So like if that point right there is 2, 4, the respective mirror point is over here minus 2, 4. In this case, it has the same y value, but the x value is just the negative. Now all these points have mirror points. This is the graph of y equals x squared, and so that's why we're seeing 2, 4 and 3, 9. So here's another mirror point right here at 1, 1. The mirror point would be over here at minus 1, 1. All right, let's look at another type of symmetry. So this symmetry we're not as familiar with because this is not a function. Remember that section about what were actual functions? This doesn't pass the vertical line test because if we run a line through here, let me run one. Oh, it's not the best line. Let me try one more time. If you run a line through, it doesn't pass the uniqueness for that given input. It has actually two outputs instead of having a definitive output. So that's why we're not as familiar with this type of symmetry. In this case, the mirror is along the x-axis, and the mirror points are reflections through that mirror. This is actually the function x equals y squared, and so the mirror points are like, here's a point, if the x value is 2, then the y value is actually the square root of 2. Now, I know that's a little hard to get used to. The mirror point on this side would be 2, minus the square root of 2. And either one of those, if you put in an x of 2, and on the right-hand side, well, if you square that y, you get positive 2 in either case. So that's why this is an unusual graph, because it's actually not a function. Let's move to our last type of symmetry. This is called symmetry about the origin. Now the origin is right here. The origin is 0, 0. And what we mean by symmetry about the origin is the mirror point is actually in the opposite side across the origin. For instance, let me find a nice mirror point. Well, here's an obvious one real quick. So if you put in 2, 0, the mirror point is over here at minus 2, 0. Now, that also looks like it's symmetric about the y-axis. And what origin symmetry really is, it's symmetric about the x and y at the same time. Here, let me point out let's look at this point at the bottom of this little peak here. So whatever these coordinates are, they look like they're about, it's like 1.1, negative 3. Yeah, 1.1, -3. The mirror point is actually up here, and it's at negative 1.1, positive 3. See how it negated both the x and the y coordinates? If you look back at the other two symmetries, the first symmetry was negating the x coordinate. The second symmetry was negating the y coordinate. In this case, we end up negating both.